AASHTOWare Bridge Design and AASHTOWare Bridge Design Rating software products are comprehensive bridge design and load rating tools developed by AASHTO. For an agency's bridge inventory, the products store detailed bridge descriptions sufficient for structural analysis. AASHTOWare Bridge Design is the tool for assisting for the design of both superstructure and substructure in accordance with the AASHTO LRFD Bridge Design specifications. AASHTOWare Bridge Rating is a tool for rating bridge superstructures in accordance with the AASHTO Manual for Bridge Evaluation, AASHTO Standard Specification for Highway Bridges, and AASHTO LRFD Bridge Design Specifications. The two products share much of their user interface and database. When both products are licensed, a bridge can be designed using AASHTOWare Bridge Design and be immediately available to AASHTOWare Bridge Rating for load rating without re-entering and validating additional data. AASHTOWare Bridge Design and Rating is capable of supporting 2- or 3-dimensional descriptions of a bridge. 3-dimensional descriptions is the basis for the 3D modeling and analysis of special vehicle configurations. The computational engines support both line girder and 3D analysis. More than 90% of the national bridge inventory can be analyzed and rated with AASHTOWare Bridge Design and Rating. The software is capable of analyzing steel, pre-stressed, post-tensioned, reinforced concrete, and timbered bridges along with reinforced concrete culverts. The superstructure types available in the software include multi-girder systems, floor beams and stringers, trusses and gusset plates, concrete multi-cell boxes, and curved multi-girder steel systems. We will now explore the AASHTOWare Bridge Design and Rating applications. The software may be accessed through the desktop icon. Using the BrDR icon provides the features of both bridge design and bridge ratings in one environment. This is the login screen where a user enters their name and password and selects the database in which to store their bridge data. AASHTOWare Bridge Design and Bridge Rating use a common database to allow the agency to store a detailed description of each bridge, which is independent of the analytical engine, including specification checking, and the user interface. The concept of storing generic bridge descriptions in a database is a powerful one with many user and agency benefits. Among the benefits are designing and rating a bridge using multiple analysis programs and specifications from the same description and input, upgrading and/or replacing components of the system, including a structural analysis engine, specification checking software, and user interface while preserving the basic bridge data, and easily linking to other related software systems, including bridge management systems such as AASHTOWare Bridge Management. The application features a graphical user interface where users can enter data to describe the physical characteristics of their bridge. The window shown here is the Bridge Explorer. The Bridge Explorer allows you to enter new bridge information into BrDR or access existing bridge information. Before we dive into exploring how to enter a bridge in BrDR, we will first review some administrative features of the software. This is the configuration browser. The configuration browser allows you to manage the users permitted to use the software. Users can be added or deleted, and different access privileges can be granted to different users. The System Defaults window allows you to set default settings for all users that connect to this database. This screen allows you to specify the default analysis engines to use for the various analysis methods. The function of an analysis engine is to retrieve the bridge data from the application, perform the structural analysis and spec checking, and return the results to the user interface for the user to review. BrDR is delivered with analysis engines developed by AASHTO for LRFD, LRFR, LFD, and ASD. Additional analysis engines are available through third-party developers. This screen allows you to select the default specification edition to use for each analysis engine. The AASHTO analysis engine supports the AASHTO LRFD specifications starting with the 4th edition 2008 interims up to the current 9th edition of the AASHTO LRFD specs. The MBE specifications starting with the 1st edition up to the current MBE 3rd edition with 2020 interim are also supported. The library in BrDR allows for the description of items that are standardized or used frequently in the description of the bridge or in the analysis of a bridge. The Library Explorer is used to navigate the various libraries. The tree control in the left pane organizes the libraries. The item selected in the tree control determines the library items to be listed in the upper portion of the right pane of the window. The database delivered with BrDR is preloaded with library items selected by AASHTO. These items were taken from various sources such as AASHTO LRFD Bridge Design Specifications, AASHTO Standard Specifications for Transportation Materials, and the AISC Manual of Steel Construction. There are three types of library items. The standard library items are items added to the database by AASHTO. Standard library items are not editable. Agency library items are added to the library by an agency. User-defined library items are only available for vehicles. When a user creates a user-defined vehicle in the Analysis Settings window, that vehicle will be stored in the user-defined library and will only be available to the user that created it. Library security is provided by restricting access privileges in the configuration browser that we just reviewed. Library access can be restricted for read, write, create, and delete access. Access restrictions apply to all libraries for a given user or group of users. This allows an agency to limit the number of users with write, create, and delete access will in turn reduce the possibility of incorrect data or duplicate and inappropriate items. There are two methods to use library items. The first method is linking, in which the items remain in the library and is then used in an analysis event. Examples of this include library vehicles in an analysis or using a set of LRFD factors as the system defaults for an analysis. Linking is used to reduce the amount of data stored in the database for items that are unlikely to be modified. The other method to use library items is copying. This involves copying the library item over to a bridge. The change in the library item has no effect on items that have been copied to a bridge. Examples of items copied to a bridge include steel and pre-stressed shapes, materials, and appurtenances. Online help can be found on the Bridge Explorer help screen. Help topics for the user interface can be found here. The support link opens a help document with links to online technical support resources. We will now review the Bridge Explorer. The Bridge Explorer allows you to enter new bridge information into BrDR or access existing bridge information. The left portion of the Bridge Explorer contains a tree. Each tree item is a folder that is used to store groups of bridges. For example, your agency can create folders to group your bridges by district or county. This is a very useful tool for agencies with many bridges. The right portion of the Bridge Explorer presents a complete list of the bridges corresponding to the folder selected on the tree. Double-clicking on the bridge from the Bridge list opens the Bridge Workspace. The Bridge Workspace houses multiple docked panels: the Workspace, Schematic, Report, and Analysis panels. These panels can be docked, undocked, moved, and resized. The Bridge Workspace consists of the Bridge and Components tabs. The tree in these tabs work like the Windows Explorer file tree, except that instead of sorting files and folders, these tabs sort out different components of a bridge. The tree shown on the Bridge tab is referred to as the Bridge Workspace tree. When entering data, you should start at the top of the Bridge Workspace tree and work your way down the tree. The Bridge tab contains everything used to define the bridge. The Components node includes items like appurtenances, materials, and steel or pre-stressed beam shapes used by the bridge. These items are defined in the Components tab. They are either copied over from the library, or new items are created directly in the Components tab. There is only one instance of an item, and it appears on both the Bridge Workspace and Components tab. If you change a value within the Bridge Workspace tab, the item on the Components tab will reflect the change. These components items are then assigned to locations in the bridge. For example, the steel material will be assigned to the steel girder flanges and webs in the windows below. Superstructure definitions are structurally continuous structures where a load acting anywhere within the superstructure affects all spans within that superstructure. A bridge can contain one or more superstructure definitions. An example would be a bridge that has one span pre-stressed concrete approach span and a 4-span steel plate girder as the main structure would contain two superstructure definitions, one for each individual superstructure. The example shown here contains one superstructure definition, which is a single-span steel plate girder bridge with 4 members. Items dealing with the superstructure are located in this region of the tree. Each member of the superstructure definition has its own tree node. Under each member node are windows that describe the physical definition of that member. The schematics of various items in the Bridge Workspace can be viewed in the Schematic window. To view the schematic, select the item on the Bridge Workspace tree and click the Schematic icon on the Workspace tab. This framing plan schematic is shown here. There is also a schematic for the Structure Typical section. And the steel plate girder has a girder profile elevation schematic. We will now perform an LRFD design review of one of the girders in the superstructure definition. A design review is an LRFD analysis and spec check of the girder to determine if the girder as defined is structurally adequate. Analysis settings and output are available on the Analysis ribbon. We will select LRFD Design Review by the LRFD method and a line girder, or 2D, analysis. Vehicles can be selected on an individual basis. For an analysis or an analysis settings template can be chosen. BrDR comes with predefined analysis settings templates that you can choose for analysis considering AASHTO prescribed vehicles. Users can also create and save their own templates to consider vehicles prescribed for their agency. Now that the vehicles are selected, we can launch a design review. The analysis panel shows information and warning messages related to the analysis process. Messages that are underlined can be clicked and the corresponding window opens so that you may adjust your data as necessary. Buttons in the Results group are now available after the analysis. The AASHTO analysis engines create detailed output for every spec article considered at every analysis point along the length of the girder. In a design review, these articles compute design ratios that indicate the ratio of the resistance to the applied force effect. If the design ratio is greater than 1, then the resistance is greater than the applied force effects and the design is acceptable. If the design ratio is less than 1, the resistance is less than the applied force effects and the design is not acceptable. Now, without changing any data in the bridge description, we can easily launch an LRFR rating of this same girder. I will choose the Design Load Rating template prescribed by the AASHTO MBE spec. The basic steps of the AASHTO analysis engine computation process is as follows. User input data describing the girder member is used to generate finite element models for each stage of the member, such as the non-composite and composite stages. The dead loads present in each stage are applied to the FE models and the resulting unfactored dead load force effects are determined. Live load influence lines are generated for analysis points along the girder using short-term composite section properties. The axle loads and lane load patterns of the selected vehicles are pushed across these influence lines to produce the live load force effects. The live load force effects are multiplied by the dynamic load allowance, live load distribution factors, and multiple presence factors to determine the unfactored live load force effects. The dead load and live load force effects are then multiplied by the load factor prescribed by the AASHTO spec and combined to produce the factored force effects acting on the girder. Specification articles prescribed by the spec are evaluated at analysis points along the length of the girder. The Bridge Workspace help screen contains links to method and solution manuals that detail the analysis and spec checking process used by the AASHTO analysis engines. The tabular results window shows a summary of the critical rating factors for the member. In addition, the unfactored dead load and live load tabular results are shown here. The live load results shown in the table do contain live load distribution factors, multiple presence factor, and dynamic load allowance. Details of the specification checks are available. A report containing these details can be generated. The Engine Output button allows you to open various output files created by the analysis. A summary report of the spec checking is available. FE model reports are also available. Graphical displays of the output are available as well. We'll now review how bridges are organized and input within the Bridge Workspace. A bridge is a structure or group of structures providing continuity of a highway across an entire crossing. A superstructure is one or more spans that have the same structural type, such as a girder, truss, or frame, and for which a load acting anywhere within the structure affects all spans within that superstructure. A superstructure definition describes the physical characteristics of a superstructure. A bridge can contain one or more superstructure definitions. A superstructure definition can be described in one of two ways. A girder system superstructure definition describes each of the girders, including the position of each girder, relative to the overall superstructure. In a girder system, BrDR will compute the portion of superstructure loads, such as deck and appurtenances, to apply to each girder. BrDR will also compute live load distribution factors for each girder. In a girder line superstructure definition, the girders are described individually without any relation to a deck sitting on them or to the location of other girders. Users are responsible for determining the dead load and live load distribution factors in a girder line superstructure definition. Each member can have one or more member alternatives. A member alternative is a configuration of materials and dimensions making up the physical definition of a member. During design, member alternatives allow you to compare different member types. For example, you can compare a stiffened steel plate girder to an unstiffened plate girder. Once the bridge is in service, member alternatives allow you to evaluate the benefit of various rehabilitation alternatives. Member alternatives can be input in one of two ways, either schedule-based or cross-section based. Schedule-based member alternatives describe all parts of the member in lengths along the member. For example, the web plate and flange plates are defined individually along the length of the member. Cross-section based member alternatives are input by selecting a number of points along the length of the beam and describing the beam cross-section at these points. The lower portion of the bridge workspace tree is useful for comparing design alternatives during the bridge design. In this bridge, there are 4 superstructure definitions for the bridge. The bridge alternative is a configuration of superstructure units making up the physical definition of a bridge. There are 2 bridge alternatives being considered here. The first bridge alternative consists of 3 superstructure units with the following superstructure definitions assigned to the superstructures. The second bridge alternative consists of only 1 superstructure unit with the following superstructure definition assigned to the superstructure. The bridge workspace can be navigated in the following ways. The mouse can be used to jump around the tree nodes. The keyboard arrows can be used to navigate up and down the tree. A window can be opened by selecting it and double-clicking the mouse left key or by clicking the keyboard Enter key. Windows in BrDR typically contain OK, Apply, and Cancel buttons. Clicking OK will save the data to memory and close the window. Clicking Apply will save the data to memory and keep the window open. Clicking Cancel or the upper right X button will close the window without saving the data to memory. To save your bridge data to the database, click the Save button in the Workspace ribbon. A validation window will appear showing you informational messages about your data. Right mouse clicking while a tree node is selected will open a menu with all the functions available for that tree node. Copy and paste functions are available to minimize the amount of data input required. Delete is another function that is also available in some tree nodes. The Tools ribbon contains a Report Tool button that allows you to generate a report containing all of the data input for your bridge. This report is useful for checking the accuracy of the input and can be included in your design and load rating calculations. The BrDR website contains many useful resources for users. This website can be accessed from this link. A support page is available to show the different ways technical support may be requested. The training page contains a wide variety of step-by-step tutorials to help new users navigate the entry of a bridge in BrDR. Thank you for your interest in the AASHTOWare bridge design and rating software.